going into building a new product or coming onto a recently built product at a startup. But that's not the only thing that's out there, and I just wanted to take like 2 seconds to talk about some of the other things that, as engineers, I mean, you've got tons of opportunity, especially in a city like this. There's going to be a lot of gifts. You could go into contract work. You could do the agency thing, ad agencies. I did that for about 3.5 years. It was exactly like that, every day. That part too. You could freelance, or you could build a product. This is exactly what app development in the startup world looks like, I think, most of the time. So before I get into it too far, a little bit about my background and why I'm up here. I'm still sort of new to San Francisco, but I'm a senior front-end engineer at Flickr. But before this, like Eric said, I was at Evernote and did the very tiny startup thing for a little while and had some agency experience mixed in as well. At Flickr, we're working on revamping the entire front-end stack. It used to be a massive PHP website. We're introducing Node and a whole bunch of new technologies into the middle to front tiers of this. And I'm working specifically on the Node.js portion. But it's really a full stack role without any of the crazy difficult back-end technologies built in. So it's, I don't know, it's really fun. But a little bit of the background of how I got here. So a couple years ago I was working at an ad agency, a digital ad agency, and my friend from that I've known back in Michigan, and he was living in Chicago at the time, he calls me up and says, hey, my brother and I are trying to do the startup thing. We're going to start a company. We're moving out to Palo Alto to try and, we've gotten accepted to this incubator for 9 months or so, and well, can I crash on your couch while I try to find a place? And I'm like, yeah, absolutely, man, just come on out. It's beautiful out on the West Coast. And so 9 months later, he and his brother graduate the incubator and secure a seed round of funding. And finally, they built this product and actually launched, and they were just starting to scale, and now, it's starting to get real, and they need to hire an actual engineer. And so that's where I came in. And so what I'm going to try to tell you guys about today is some of the big problems that I saw with this app as you moved from, just starting out and getting the user base to massive scale. I mean, well, massive scale for a startup, we're talking maybe like 3.5 million users is I think of what they ended up with a couple years ago. But yeah, there are definitely some common problems that they ran into and that I've seen over the years with similar products. And what I want to get into a little bit first, though, is, well, okay, yeah, sorry. Yeah, I really practiced. So what a startup looks like from concept to scale, basically the business portion of it. Some common problems that startups face in general, and these will be like the technical ones. And then some good solutions to these problems. And you were talking about what was the segment you just did?
Everyday carry?
Everyday carry, I'd never heard that term, I love it. This will be a little bit of everyday carry actually as well. I didn't want to speak up at the time, but for each of these problems I'm going to try and give you at least some links and solutions to go on. And I'll work with Eric to post this up after we're done here, and you guys can go in and, well, hopefully you can make use of some of these. Most of the all the problems that I'm going to present here are not really tied to Ruby or Node or any specific technology or startup for that matter, but a lot of the links I'll be posting are Ruby, just because I know that's what you guys are going, most of you are working with, and well, that was what I was using to solve these same problems at the startup. So first, what a startup looks like from the start, like the business side of things, is basically a really, really simplistic process. I'm going to really oversimplify it, but basically you get an idea, you have to build it, because if it's vaporware, it's never going to make money, or people aren't ever going to use it. Then you have to get money somehow. And after that, just try not to panic. That's exactly, when I saw this one, I'm like, this has to go in, because this is exactly what a startup's like. You're like, that right there is exactly what it's like. I just want to see it again. Yeah. All right. So, at a young startup, it's a lot of business. Basically, powered by a little technology. You're working to get something out the door, but it doesn't have to be polished, and it probably won't be. It'll probably be a really hobbled together website or app or service or whatever, which the customer may not know, but being in it, you'll probably see that. One of the concepts in, you've probably heard this before, is the concept of a minimum viable product. And that is basically, the fastest, smallest piece that you can get out the door that's actually going to be worthwhile to somebody. So either they'll pay for or use or whatever. Throughout this process, the startup is going to be working on trying to get another term you've used or heard of, their product market fit, which basically means what you build the first time might not be of use to anybody. So what you got to do, you've also probably heard the term pivot. This is where a startup pivots, where they say, okay, wait, what we've built maybe isn't solving a problem, or maybe people aren't willing to pay for it, or whatever, so let's shift gears. Maybe we can reuse most of what we've done, but slightly position it differently, or maybe we can change the intended audience of the product, but basically just figure out where you fit. Another thing to note is that your founders may not be engineers. It's pretty cool if they are, but they might not be. They might actually just have these really great ideas. But when you guys come in and you are taking over this product, it might not have been built by someone with the training that you have had. It might have been someone that has just been reading tutorials, if you're lucky. So I guess to explain, what the founders have been primarily interested in from the start is profit, if they can get profit. Not often the case for a startup that small. So if you can't get profit or any revenue, clear revenue streams, you're looking for traction, which is basically how many users can you gain? What is the acceleration with which you can grow your user base and give value to people, even if it's for free. Traction means so much nowadays that I think the idea is basically later on, if you decide to charge people, even like some fraction of a % comes on, if your user base is huge, it's still going to make you some money. After traction, you're looking for funding, probably, and investors love to see very good traction. So that's basically the concerns of the business side of a young startup and the problems that they're facing. Notice that none of these are really engineering problems, which is where you guys potentially would come in. I'm not a business guy, so that's like the business problem section of this thing. Now I want to get into telling you about like the engineering problem section. And this is also a lot of what it looks like. So some of the big problems that you will come across, not only in startups, but I mean, this could be at an agency, this could be at big companies. These are products that are universal pretty much, but I'll talk about how they apply to a startup and a small business. And what I also want to go through on each of these, is let me back up just 2 seconds. What I also want to go through is sort of, for each of these things and each of the solutions that I provide to you, I want to talk about the business justification, because when you're this small, it's not always about like playing with the coolest technology. It's about like growing this small business, because ultimately that's what's going to appeal to investors, and that's what's going to get you guys money to continue doing the things that you love doing. But there are totally ways to do it with like really cool technology. So your app that you come onto may have a horrible or missing test suite. And I know you guys all did some sort of test-driven development in your lesson plans, which is great. You've probably heard the term monolithic code base. This is, that's a big problem when you're rushing to build things. It's it's something that can happen. You might have to deal with a painful deploy cycle. You might come onto an app that's unstable, and you might come onto an app that's super slow. And none of these are good things, and all these are like big problems that need to be fixed, right? And the solutions might not be immediately clear. So I'm hoping to break them down a little bit and give you some really easy, good wins, that'll give you a lot of bang for your buck. So, start with the first one, the test suite. Every app needs a test suite, or else things look exactly like this. It is way more difficult, and you guys probably know this from your curriculum and everything. It's way more difficult to do test-driven development and BDD and everything in practice than it is in theory. It is an entire discipline of software engineering in and of itself. Not every software engineer out there subscribes to this or knows how to do it. It's really tough. And if your startup even has a test suite, you are lucky. When I started at the startup that I was at, we had a test suite that was sort of hobbled together. One contractor had come on and written a couple tests for us, but they really didn't test much of anything in the app. It was all mocked out, and but there was probably still about maybe 15 to 20% coverage. Not that we put a priority on this, but I love test-driven development, and we got it up to, I think, in the 70s or 80s, which is completely acceptable. You don't need 100% test coverage. No one's ever going to get that, and it's not necessary. But getting up in the 60s, 70s, 80s is really nice. How did the problem come about? Well, the original people at the startup needed to build these features quickly, and a lot of times the test suite, sort of gets in the way, or they didn't know how to do it, and they were going to spend too much time on it instead of building features, so they deprioritized it. Yeah, similarly, it takes a whole lot of effort and discipline that they may not have had at the time, given that the founders might not have been trained engineers. So one of the things that you'll hear is, well, maybe we should go the TDD route, test-driven development all the way. What a lot of people won't tell you about TDD is primarily an interface design process, meaning when you write tests, when you develop in a test-driven way, you're designing the interface of your units, of your components, to make sure that they work with each other and you can use them in a suitable way and in an intuitive way. It's not so much about testing functionality. That's definitely a secondary goal, and it lets you know when things break. Yeah, you go about testing the smaller pieces of a project, which means that you probably need smaller pieces. If you have larger units and concerns in your app, it's going to be way harder to test them and test them independently. Furthermore, test-driven development in trying to retrofit that is not always practical. Meaning that given that test-driven development is used as an interface design process, if your interfaces are already there, I mean, you're testing existing behavior, not trying to do new stuff. If you ever have to refactor or replace something in your system, definitely go TDD. I'm not saying it's bad, but it's really hard to retrofit. If it comes time to argue for TDD, well-factored code can change faster to match requirements, and well-tested units don't break very easily. You've got an automated test suite to catch these things fast. Developers like working with good API design. So, if you come across a library or a gem or anything that's really well written and you just feel it and it's intuitive, that's one of the things that's so great about Ruby, is it's so intuitive. that just, it makes you happy to use it, and it makes you more productive because you can move faster. You can sort of just guess and it works. And developers love having a test suite. I know if you've ever worked with or on a project that, if you do something wrong, a test breaks immediately, telling you that you did something wrong, or that's nice, and developers love to have that security. What might be easier at a startup, though, is what are called acceptance or integration tests. Now, Rails has these built in, and it's really easy to test this as well. But basically, what these are test criteria for software delivery, meaning they test the overarching aspects of the system and basically what we would call an acceptable product to ship. They test the happy path for the user, meaning that all the big features that you want, they don't concern themselves with the little units. They concern themselves with the system as a whole. So if you have a new feature, writing a test that feature even works, and you know it works before you ship, that's great. You can always do this manually. In fact, you probably have, and there are places that have entire departments dedicated to QA, which is basically this, but in a manual way. They're clicking around the site and watching for things to break, but it's way better to automate this if you can. Business justification, you never want to break a feature for the user if you can avoid it. Probably will, we all will, but you never want to. So to have an automated way to detect that is really nice. It's great to test every feature if you've got a test suite, not just what you're working on. Because you know that sometimes when you're working on component A, you can totally mess up component B inadvertently. So it's nice to have the whole system covered if you can. Acceptance tests also can be run on different environments and browsers and devices. So those nasty IE8 bugs that I hate. I don't even have a VM on this thing. I hate it. I probably should, and don't tell my boss that. Oh, that was the beer talking. All right. So yeah, but I don't like doing it. But I'd much rather have an automated suite that will catch that sort of stuff for me. So, Linky time. These are some tools that you can use to help you achieve this sort of stuff. I'm sorry, that's like way trickier on this screen than I intended it to be. But at least his face does he look like Brendan Fraser to you? Okay. Cucumber is an acceptance testing DSL. So I don't know. Did you guys learn about Cucumber in code school or anything? Okay, but you learned about Archspec. So Cucumber is really kind of nice. I would check it out. It's not just a Ruby thing, but what I'm pointing to here, it was written by Aslak Helisoy, who's a big Ruby guy. Basically, it's a domain-specific language for describing a user flow throughout a site. And you set up expectations that way. Like when I click this link, this menu pops down, and then in that menu, I fill out the form and click submit, and then I should have a new, who's what's it. But it's really, really nice, and it's in fact written in plain English, like all of the acceptance criteria. So it's really easy to get your business types on board with writing and understanding this sort of stuff. And yeah, so there's that. Approval tests are another really, and this is a shameless plug on the bottom there, but Katrina Owen wrote this first library, approvals for Ruby. Approval tests are a really nice way to retrofit tests to a system. Basically, they say, if I get this output, whether it's the result of a method or the return value from the response from an API endpoint or whatever, you capture it, literally write it to a file, and then the test becomes a diff every time thereafter. And if that diff fails in the future, your test fails because it's different than what you approved. So it's really cool for shoring up behavior of existing components. When I went on to the startup, the first first week I was there, my buddy was like, "Hey, we're about to launch our mobile API." 0 tests, no tests, and we all know that if a JSON API changes anything, the mobile client could completely break, and then it's another 3 or 4 weeks while Apple approves a new app or something. So I went and wrote approval tests for everything, just captured it, and I don't care what it did under the hood, I just didn't want it to change. So And finally, Saucelabs is a really nice platform for automated Selenium testing. Now, Selenium is just like a browser driving framework. I said like Cucumber will let you click around and say, when I open this menu, I expect to see this text or whatever. Selenium is the thing that's controlling the browser. So that's the little plugin for Firefox or whatever that'll do the clicking. Saucelabs will let you run those tests in the cloud on all these all different platforms, all different browsers. Really nice stuff. So yeah. Cool. Next one. A monolithic code base. This cat is so fat, I had to do it. So you've heard about like really fat Rails apps and stuff. This is what it looks like to me, where it can't even scratch itself. When you hear the term monolithic code base, you often hear that nowadays tied in with a Rails app, but it's not a Rails specific thing. This is really just like Rails makes it easy to build a huge app, but you can build a huge app in any language, and it can be just as much a mess in any language. This is not a Ruby specific thing. I love to tell people that because it's like, I don't know, Rails has this stigma for letting you build large apps. Well, that's because it's easy to build large apps that work and actually ship. But still, it's going to take discipline to break that down. Monolithic code bases, sometimes it's very difficult to tease apart these features, and you can tell here that we're probably getting into the realm of like service-oriented architecture, right? You guys have heard that term? So I'll talk about that in a minute. But it's really hard to break these things apart and test them, like actually get them separate. Most companies run into this problem, not just startups, like every company. We're going through this at Flickr right now, talking about how to make our huge 10-year-old PHP app into services. And so it's a problem that everybody runs into. How did we get here? Probably built by engineers that didn't know any better, had to move too fast, or had never heard the term service-oriented architecture. It's actually, the discipline of it is kind of a recent thing. They had to get to market as fast as possible, if you want to beat the competition. So who has time to build services? Who has the team to build services? So, but we'll talk about that next, because that's exactly where your mind goes, right? So what this is basically breaking apart your large app into several smaller functional services. Now these could be written in different languages if you wanted to. It doesn't have to all be the same. They could have different databases that they talk to, or even, or whatever, or no database at all. They communicate with each other over the network. Typically this is going to be HTTP, but you could really use any protocol you want. But the idea is that they're completely separate. They'll be different like Heroku apps or anything. Some good candidates for services, you can make anything into a service really, but the URL shortener, instead of tacking that onto your big app, that's a really easy one that you can just put over here. Instead of making it backed by Postgres or something, build it up on Redis or something, I don't know. But that's a really easy one to just bite off and put over there so you don't have to worry about it. Image upload or asset services. You've seen nearly every large scale site out there has their own image.whatever.com. It's a really nice chunk to break off. Why should you do this? It's because individual services are easier to build, they're easier to test, they're easier to maintain. If I have to test the service that's just really tiny, that's going to be mad easy, and I'm going to get to build it faster. Maintenance only affects that small part of the whole system. So if I only have to take down my URL shortener for a bit, and that's not going to affect the rest of the users, that's great. Because users hate downtime and maintenance pages if you can avoid them. It also allows you to use the best technology for any given service. Like I said, if you wanted to build your shortener on Redis instead of Postgres or whatever, whatever you choose to do, you can totally do that without trying to shoehorn it into your existing app. What might be a more interesting approach that is less risky, especially if you still have a small team, is we're talking about modular architecture. Instead of breaking off services into different like apps, because a whole app is, it's still a whole thing. Break off parts of the code base into well-tested modules. Make your, if you've got this nice little piece of functionality, make a gem out of it. Test it, either publish it or point directly, have your gem file point directly to your private repo or something. And then that part is out of the code base. It's, and it's well-tested, it's dependable. If you make it public, that's great too, and then other people can use it. You can make it, you can get their feedback, help them fix bugs. Clearly, it's easier than service-oriented architecture because it's it's a smaller portion. All you're doing is making a gem. You're not making a whole app. This is really easy in languages with good package management. Luckily, we've been talking about Ruby and Ruby gems. It's one of the best out there, honestly. Node.js and NPM, fantastic. Python's great too. We're lucky that nowadays nearly any modern language is going to have excellent package management. So this sort of technique is really, really feasible. Just like services, modules are easier to build and test and maintain because they're smaller, they're focused. You can share code between services. If you had to use the same sort of library between the different services you build, as long as they're in the same language, you can absolutely share the code, and that's even better. It also lowers the cognitive overhead for your developers. The less code that you have to see in front of you and keep in mind, the faster you can move and concentrate on what's important. And like I said, there's the potential to contribute modules back to the community. Open sourcing stuff is one of the, I absolutely love it. Writing code for the public is so much fun. And the feeling when someone either uses your project or contributes back to it and fixes a bug or whatever, like there's nothing like that. And if it helps contribute back to your business, I mean, that's fantastic. I don't have any links for this one, actually. There's no linky time. But, you get it. There's a whole lot of open source stuff out there. Painful deploy cycles. Did you guys all use Heroku when you were doing the Code Academy stuff? That's great. I love Heroku, and a lot of startups will be on it simply because it's so easy and it takes the whole pain point out of your ops team. I mean, you probably don't even have an ops team at most startups, which is great. But this can still get kind of painful if if you're either not on a platform like Heroku or you're a whole bunch of other stuff that crammed into the app. Startups need to, I know we keep saying startups need to ship features quickly, but someone will, at some point, deploy bad code. I did it just the other day. Yeah, I got some shit for that. But it's all good, because if your deploy cycle, unless your deploy cycle is painful, then you can't fix it as fast. You need to be able to fix stuff and ship product or ship features very quickly. Plus, the more manual your process is, the more chance that someone's going to screw something up. How did it happen? Well, your founding engineer might have been working alone, so they don't need to collaborate with the team. When I came on, the guy that had built our site, he was the only guy, and he had so much stored up here that I had to sit him down and pick his brain constantly, because so much of the process for hitting the button to getting code on the server was all up here, and it wasn't even like scripted or anything. So that's a problem, because when I come on, I need to be able to do the same thing that he's doing. Downtime has less impact when the user base is small, so they might not care about having a maintenance page up for enough. But as you grow and you get more users, that becomes an issue. You don't want to show them that maintenance page for too long. And of course, big apps take longer to deploy, so the time it takes for your app to boot or your test suite to run or whatever, that goes up as well. So this one will be pretty quick, but what you really want is a push button deploy. You want to be able to hit escape or hit enter, don't hit escape. Hit enter and have your code just right onto the server and relaunch. If you're using Heroku, you pretty much already have this. They give you a lot of other tools, but you more or less have it. Another idea is, so you don't hit a wrong key or forget to do something, like run database migrations and therefore break any code that relies on or that expects a new schema. We did that a bunch. You want to be able to automatically tag releases. That's one thing that you can do in, create a Git tag of a release. So if something does break in the future, you go back to a known state that was really good. It'd be nice if your maintenance mode page turned on and off automatically, so that you don't forget to do that, or users try to hit your app while it's down, or forgetting to run the tests. I mean, that's a big one. So many people push code without actually, don't even think about it. You get caught up in writing, but you don't think to run all the tests, and could have broken something else, or not even work. Business justification is, less downtime. You can move faster when you deploy faster. Yeah, more length time. One of the coolest part. So, is anyone familiar with Git Hooks? Cool. So, these are great. So, Git. I assume you guys were all using GitHub and Code Academy. It's the best. But one of the things that Git can do is run a whole bunch of hooks throughout all the life cycle actions of your source code. So, pre-commit, you can run a pre-commit hook that basically says before this commit even takes effect, you can run your tests or whatever automatically for the user. Similarly, I don't know, they've got hooks for all sorts of the life cycle. That's really nice for not having to remember to do stuff every time. You're going to commit code anyways, so you might as well just have it baked into your process. Git Deploy, this was kind of cool. There's a bunch of tools out there that do stuff like this, but I was helping write this one. It was basically an extension of Git Hooks, but it's a whole bunch of really deploy-centric scripts based on deploying via Git to Heroku. I'm not saying it's the best thing out there, but there's some cool ideas. It's worth checking out. And finally, Hubot is, have you guys seen Hubot? This is GitHub's IRC bot, basically. It's written in Node, and it's completely hackable. You should definitely check it out for fun, if not for getting it set up at your company. But he sits in our IRC, and basically, or in in any sort of chat room adapter, and he can deploy your site. You can call people names. You can bring up GIFs. It's really productive and not productive at the same time. But you can actually get him to automate a lot of your stuff. So that one's pretty useful and fun. Site instability. This one's super gross, but it's bird-eating bugs. It's a lot of bugs. Yeah. Every application will have bugs. That's that's a given. They're going to be there. One of your first tasks at a startup or at any company really is probably going to be taking on existing code and fixing bugs. Every website you use, this is the dirty little secret, every website you use is way more broken under the hood than you think it is. It's all messed up. And yeah, it's hands down every place. Why is this website so crappy? The one that I just got hired to work on. Same stuff, it sounds like a broken record, but at the start of a startup, features have been rushed to market. So they're going to make mistakes, and features are going to be half-baked. They may not have tests supporting them. So how do you fix these bugs? You probably went over some sort of bug fixing process during your courses, but it's always, always, always easier to fix a bug that you can reproduce. So step one is try to figure out how to make it happen again. This is especially important when you get to a site that's live. So a lot of places have your production environment, which is what you would call your live site that the end user uses. But you probably also have a staging server that's basically an app just for developers. This is a good place to try to reproduce a bug if you see it, because you're not messing with anyone's data. Even better is to try and reproduce this stuff locally. So Rails lets you run your server locally. that's the best place to do it because you can break stuff and it's not going to affect anybody. So the other thing that you can do, and this, I swear to God, they didn't talk to me about this at all, but monitoring is so huge, and New Relic's like the best tool out there for it. We were using it at the startup. If you're on Heroku, they've got like a drop-in integration, and it's fantastic. And you get so much like deep dive into what your code is actually doing, like per method call. See what's slow, where the error might occur. It's so great. So you should also be using profiling tools to identify pain points in the app. Again, New Relic comes in there. Using a metric service to track monitoring specific stuff. I should have rethought that bullet point. That doesn't even make sense. But yeah, like just there are services out there to help you instrument your app and gain insight into what's going on if you can't reproduce things locally. So first up, New Relic. If you're on Heroku and you're building an app, drop this in. It's fantastic. You can get started for free. And we can fix so many bugs just by what you get for free. It's incredible. Metrics is a Ruby instrumentation library. Came out a couple of years ago. It's a really cool DSL for just basically, I don't know, tracking other events within your application or timing things, whatever. And Duxboard. Your app should probably have a dashboard where you can, at all times, sort of see these metrics in real time. New Relic gives you that for the stuff that they instrument. And actually, yeah, cool stuff on that front. But yeah, your company should have a dashboard so you can see what's going on. And finally, we'll talk about site slowness. I had to go with the slop. You know, like, you have to. As your application grows, performance becomes a concern. Users always want a fast, responsive experience, and you know, I could have brought up all sorts of surveys and statistics about how important this is, but just, I mean, you've probably heard a lot of them too. Like, it's so important how, you know, to make your site fast. Now, this does mean perceived performance is a lot more important than, well, is most important to a user, I think. I put a lot on there to be politically correct, but I think it's most important. And this is why there's a lot of techniques out there right now, like, you know, Ajax and Pjax and turbolinks and all this stuff to just sort of decrease the perceived load time without really changing much in your app. But this does mean that all levels of the stack must be fast. If your database is slow, your front end is not going to be any faster. Slowness always compounds over time. Like, you might get lucky and have one part of your app that's like really, really, really slow. Because, I mean, and I say lucky because then if you fix that one part, you get this huge gain. But it's probably not going to happen. It's probably going to be a couple of things that are contributing to whatever's slow. It can come from anywhere. The code may be slow. Someone might have written inefficient stuff. Your database connection, like your database schema might be super slow. You might not have it might not be well architected. Or your assets, you know, if they're not minified, concatenated, all this stuff. That can cause significant slowness on the front end and perceived load time. So how do you make it faster? Profiling. You got to find out what's slow. You know, just like how if you wanted to track and try and fix a bug, you got to figure out what is slow before you can even, you know, try to fix it, identify it. And New Relic helps out so much with that. If it turns out your database or your code is slow, if you can move it out of the request cycle, that's huge. So are you guys familiar? Well, I'll get to one of these, but you've heard of background job or Sidekick or rescue. These things are all task queues, and basically the idea there is instead of during the request response cycle doing a whole bunch of work, if you can move it into the background and just return something to the user faster, but do some work later, that's a big win. So whatever you can offload in the background is great. N+1 queries, I'm not going to go into too much of what this is. If you do some reading on Active Record and the way Rails will help identify these for you. But basically it's when you have an association and by fetching the first record, you get tons of other records with it, and each of those end up being separate queries that can pile up really fast. So those can be fixed really easy, and it's a big win for cheap. Fourth, database indices. These are great. I wouldn't go just slapping on indexes wherever, but really, like dig in, see where we get like the biggest win. But some of the slowest queries I've ever dealt with are because it wasn't planned out to ever put indexes on them, and then you put one on, and it's like orders of magnitude faster. PJAX and friends, Rails 4 and Turbolinks, like you can just drop that in and basically. Are you familiar with you guys for the most part Turbolinks? Well, so basically, PJAX. The idea there is instead of building like a JSON endpoint to serve data off your app, use Ajax to request HTML and then just drop it into the page. So the page never refreshes, and you don't see the flash of unstyled content and basically the traditional page navigation. It still feels like a single page app. And in fact, it is. But that's the idea there because it really decreases the perceived load time. Rails 4 and Turbolinks. Turbolinks was another library that was written by DHH. And so there's tight integration there. You can pretty much drop this into your Rails 4 app and it'll just work. And it's amazing how much faster a site will seem after that. So look into that. And finally, page caching. I put this last because, like I said at the start of the talk, the hardest problem in computer science that they always say is cache invalidation. This can really bite you if it's not done right. Any large-scale site will end up caching pages, but you should probably wait as long as you can to introduce a caching strategy. So, link time. Sidekick is super dope. Sidekick is background processing for Ruby. It's written by Mark Perham, super smart guy. Sidekick is really cool because it uses Ruby threads. Threads or fibers that it uses. I forget offhand, but not separate processes. So the idea here is instead of running like one background worker is what they call it per process, you can actually run multiple workers per process, meaning if you're on something like Heroku, you don't even need like another dyno to run this stuff. And we had initially at the startup, when we were moving all of our stuff into background queues, we were using Rescue to start, and it was costing us a significant amount of money to use all the extra dynos, and I think we cut them down to a third by using Sidekick. I forget exactly how much, but we saved a lot of cash. Turbolinks, like I said, really great, super easy win. Finally, Google. There are tons of great resources online for talking about like speed optimization websites, especially when you go to like Node or Rails. There's lots of great things you can do. That's about all I had. So I don't know. I hope that I wanted to leave a lot of extra time for questions, and we do have some, I guess. But yeah, I hope that I gave you guys some tools to that you can immediately apply to whatever projects you're working on, or the next project that you step into. Stuff that can hopefully give you quick wins in scaling. These aren't the most in-depth solutions, but these are definitely ones that you could probably make use of, I hope. So, thanks. Yeah, if you guys have any questions about anything, what we talked about, otherwise, how are the Olympics going? That's my question to you. How are they going?
Someone asked a question.
Can you give some examples of use cases with Sidekick?
Oh, sure. Yeah, absolutely. So let me. So the startup I was working at was basically a messaging platform for students, and we would have to send out a whole bunch of emails and text messages, and we were we were doing that all in the request loop. And you can imagine that if I have to send out 30 text messages and 45 emails or whatever during one request, it's just, I mean, that's going to take forever. So the idea there is move all that stuff out of the background. So basically, when the request comes in, say, you know, the teacher hits send, we move that job into the background. So all those text messages and emails get sent out, but she hits submit, and then she gets something back immediately that says, yep, you sent your message. Furthermore, instead of doing all those, you know, 75 things at once, you can split them up and have 75 different jobs queued up, so they all run in parallel. And with something like Sidekick, that lets you achieve massive concurrency with that, I mean, it gets done like that. The other things that this is good for is like, I mean, sending emails is a big one. Metrics are good. You know, if you have a ton of stuff you want to track during a request, basically anything that takes a ton of time. A lot of things like if you even are creating a new record in the database, or editing a record, or whatever, and it doesn't need to be, creating is probably a better one, but something that doesn't need to be visible to the user immediately, by the time you return, you can put that into the background and just put it off to later. And they'll never know the difference, but they will see the sites like way faster. So.
Would you recommend AWS at all for if you're just starting out with an idea and seeing, you know, how to get traction?
Sure, absolutely. I mean, depending on the technology you're going for, but I mean, nowadays Heroku is so easy to get. I mean, like, I didn't intend on plugging Heroku, but man, I love Heroku. It's so easy to get up and running, and they've got a container for nearly everything nowadays. So no matter what technology you're looking for, whether it's, you know, I think they even do PHP if you wanted to. So it's AWS though is very nice, and if you're looking to get into any sort of scale and money is a concern, I know I believe it happens to be cheaper. Don't quote me on that, but yeah, AWS is nice. However, Heroku it doesn't get simpler. They've made a user experience out of it. You know, that's part of their business, so it's super nice. If you're running other sort of things though, you know, that maybe you wanted to run, well, I was going to say like something a little more complicated, like a Redis instance or something, but then again, they've got hosted Redis nowadays too, or like a Mongo database or something. Like this is all there are companies that are doing all of that now. So I don't know. Yeah, I love AWS, but it seems like there's a hosted solution for nearly everything nowadays. It's pretty cool.
So I know you mentioned database indexing and optimizing queries. At what point would you consider other strategies like denormalizing or splitting the database, and what else maybe would you
Totally.
consider?
So along with page caching, I'd leave off sharding your database or splitting it as long as you can. Sharding gets it like really complicates things, especially if you haven't quite figured out what you want to shard on. So sharding for you guys is basically you split up your database into several databases based on some sort of criteria in the record. So maybe it's like, if I know that my users are grouped heavily by ID or maybe the date they joined the website or something, I could shard on user created at. And based on the user coming in, I know which database to point you to. It's a simplified way of thinking about it, but it's not always that clear. And if you're not very clear on it, you could be shooting yourself in the foot very early by sharding too early. Let's see, what was the other approach that you mentioned? Sorry?
Denormalizing.
Oh, denormalizing. I would also leave that a little bit off, but I mean, that's not as bad. In fact, that's very akin to like, there are gems out there that can really help you do that sort of thing. Like, in effect, like your counter caches are also sort of a denormalization. Not quite, but that's basically a very, I don't know, a very simple form of denormalization. So you can get some pretty big ones out of that early, but it's again something that you really should think about.
Yeah. When you jumped into your startup, you said it was somewhat monolithic code base, and there's a lot of code, no tests. What was your best strategy for going from 0 to 80% test coverage?
Totally. So I mean, it wasn't too fast. It probably took me a year to do that. So the first thing that I did, like I said, I had to. One of the strategies that I did was to lock down a whole bunch of the parts of the app that I wasn't sure about by using approval tests. Just to have a test run part of your code that wasn't previously running is going to help that number go up. After that though, they did realize that there were a lot of parts of this app that needed to be refactored. And I had convinced the guys that, we need to build features, but since the app was already live, we needed to make it safer for our users to use. And if there was a lot of volatile code here, one of the best things we could do for our users is to refactor the app and make sure that all of these components were very well tested and well lubricated. So it's really nice when you have somebody advocating for that sort of process. I mean, to fix things that are broken instead of keeping pushing forward. So I guess I was very lucky in that respect. But yeah, through redesigning and re-architecting portions of the app, and thereby applying tests to them when we, built the new components, that's a very good way to increase the code coverage. And then I guess finally the last part, delete code. Yeah, just get rid of code. If there's something that sucks or it doesn't work or it's broken, and you can get rid of it safely, that's huge because more tests helps that number go up, but so does less code. So I love deleting code.
Sorry, along that lines as well, how do you measure the 60 to 70% fully test completion range?
Oh, okay. So there are a couple tools out there that will help you do that, and they'll plug right into whatever test runner you're using. Let's see, what is it? I think it's RCOV or LCOV it's LCOV nowadays, right? It's the Ruby de facto. Is there a new one now? I've been in Node land for a little while, so I don't know. Okay, but there are several gems out there that will plug right into RSpec or Minitest or whatever you're using. That at the end of your test run, they will have instrumented Ruby during the test run, and they know exactly line by line what parts of the code got tested and what parts didn't. And they'll give you not only a percent coverage of the entire app, but you can typically break down into each file line by line and see what methods got run and which didn't. So really easy to identify what parts of the app you still need to test.
Do you have any more, examples off the top of your head of this perceived speed sort of thing?
Sure, yeah, you bet. So, I mean, there's a whole, so I pretty much got into some of the server-side stuff where basically it's, you're requesting, on every link, requesting the page via AJAX instead, but there's tons of stuff that you can do, browser-side, client-side, to get this. So concatenating all of your JavaScript and minifying it into one file, because HTTP requests are blocking typically, and so you're, this really helps. If you only make one request, it's going to help the user feel like the site's faster. Similarly, a lot of people will prescribe you putting your assets at the bottom of the page. Some won't. Again, it's really up to what you're doing. It's going to be the best indicator there. I'm not going to jump on either side of that, but there's definitely different ways that you should treat your assets, minification, concatenation, and place that you're loading. That it's going to help people think that the site feels faster. Images are a big one too. There are a bunch of pre-made tools out there. Image Optim is a good one that basically really crunch the size of your images. They decrease the color palette and everything and make sure that they're loading very fast. And you don't see any difference in quality. This can be significant in terms of the load time of your page.
What was that one called?
Image Optim is a really good one. I believe that one though is just it's a combination of a whole bunch of smaller tools like PNG Crush and all that. But Image Optim is, if you look up that, and I believe that they've got a Rails plugin as well. And I'm sure somewhere in the README it'll tell you exactly what tools are working under the hood.
Thank you.
Right on.